Hello guys, in this video you will see whether the aspect ratio of a mesh really affects the convergence of the results or not. Let us check that by using a simple case study. Let's open ANSYS workbench and I am double clicking the fluid system, right click the geometry, create new design modeler geometry. Let's do our analysis with a simple 2D flow. Let us create a sketch in XY plane, change the units to millimeters, click XY plane, click sketching, click the Z to view the XY plane, create a rectangle with the dimensions of 500 cross 100. So now we have created a domain which is having a length of 500 millimeters and 100 millimeters height. Go to concept, surface from sketches, select the sketch, apply and click generate. We can close the design modeler, double click the mesh. Let's name the inlet and outlet boundaries. This is the inlet and this is the outlet. And let's give sizing for this side and this side. Click Ctrl and select both edges. Right click image and go to Insert Sizing. And I am giving an element size of 2 millimeters. We have to disable the capture curvature so that we can change the behavior to hard. So only when the behavior is hard, it will apply the size what we have defined here. Otherwise, the default meshing algorithm will override the mesh size what we have given. And select the top edge and bottom edge. Right click the mesh, insert sizing, and provide element size of 2 millimeters. And similarly, change that to hard. So now we have given the vertical dimension of 2 millimeters element size and horizontal also 2 millimeter of element size. So that corresponds to 1:1 ratio. So now the aspect ratio will be 1. Now we can see a non-uniform mesh. So in order to generate a uniform mesh, click insert, face meshing, select the face and click apply and click generate mesh. Now you can see I have generated a uniform mesh. So you can also see that matrix by the image itself. We can see the element aspect ratio is 1:1. We can also check that in the quality mesh matrix, change that to aspect ratio. You can see minimum aspect ratio is 1, also the maximum aspect ratio, average, everything is 1. So now we have created a mesh which is having an aspect ratio is 1, which is ideal. That is the maximum good aspect ratio that we can achieve. So let us do a simulation with this and let us do a set of experiments. So we have two vertical wall and horizontal wall. So in the vertical walls we will keep a constant mesh size of 2 millimeters. The horizontal wall we can keep a mesh size of 2 millimeters, 4 millimeters, 8 millimeters, 16 millimeters, 32 millimeters, and even we can do with 64 millimeters. So let's keep this as constant. So the aspect ratio will be, so as we have seen, this is aspect ratio. This will be having aspect ratio 1, 2, 4, 8, 16 and 32. So this is the maximum aspect ratio that we have chosen. So we expect that the result of aspect ratio 1 will be having good convergence, and the case with the aspect ratio which is having 32 will be having very bad convergence. So let's check that convergence by seeing the result of number of iterations which is taken to converge the result. Now let's close this meshing module. Right click the meshing module and click update. Now double click the setup, click start. In the boundary condition, provide a velocity value of 1 meter per second. And leave all other values as default and go to run calculation and provide a number of iterations is 500, and by default the convergence criteria is set as 10 to the power of minus 3. Let us leave that as it is, and let's see how many iterations is taken to achieve that convergence of 10 to the power of minus 3. So now we can see the solution got converged. It has reached 10 to the power of minus 3 in 34 iterations. So let's note down. So in 34 iterations, the solution got converged when the aspect ratio is 1. So now let's move on to the second case, which is having an aspect ratio of 2. So that means the horizontal cell will be having larger size than the vertical. Now close the ANSYS Fluent, go to the workbench, double click the mesh. Now we can see inside the mesh we have two edge sizing. One is the vertical edge sizing. Let's leave that to 2 millimeters, and let's see the horizontal edge sizing that is set as 2 millimeter. Let's change that to 4 millimeters, so that if we generate the mesh, you can see the horizontal dimensions of the element is larger than the vertical dimension, that is 2 times the vertical dimension. So now the aspect ratio will be 2 is to 1. That will be the aspect ratio. So we can check that inside the quality tab also. Now we can see the aspect ratio is 2. Now let's close the meshing module. Right click the setup and click update to update the recent mesh in the same settings. And once you see the blue tick mark in the setup, you can double click the solution to run the calculation. The updated mesh with the same settings, same boundary conditions, with same solver settings, just keep as it is and click calculate. And now we can see the solution got converged in 26th iteration itself. So now you can observe that in aspect ratio 1 the solution got converged in 34th iteration, but when the aspect ratio is 2, it is generally we think that the solution will get more iteration to converge, but it converge in even lesser iterations. Let's close this, double click the mesh, change the edge sizing to 8 millimeters. Now this is even larger. You can observe the mesh size. Now the aspect ratio is too much. You can see the quality. The aspect ratio is around 3.9, that means 4. As we have calculated, it is 4. Now let's see how much iterations it is taking for getting convergence of 10 to the power of minus 3. Right click the setup, update, double click the solution, click calculate. And now it got converged at 53rd iteration. So for aspect ratio of 4, it got converged at 53rd iterations. So now it got somewhat larger number of iterations when compared to the previous cases. Let's see for aspect ratio 8. Close the fluid, double click the mesh, expand the mesh and change this to 16 millimeters. So if you update the mesh, you can see inside the quality the aspect ratio is 7.8, that is nearly 8. So as per our calculation, that is 8. So let's see how much iterations it takes. Now you can see the mesh is too larger in the horizontal direction. The aspect ratio is more. Let's close the mesh, right click the setup and click update. And now it got converged in 40-second iteration. It's again a drop. So the convergence is not behaving linearly with respect to aspect ratio. Let's go ahead with an aspect ratio of 16. Expand the mesh. Leave the vertical as 2 millimeters and leave the and set the horizontal as 32 millimeters. So now the horizontal size is too large. You can see the aspect ratio is too much. That is that corresponds to a value of around 16. Let's check that. The quality, that's around 15.6. That's nearly 16. Let's see how much iterations it takes to get the convergence of 10 to the power of minus 3. And for an aspect ratio of 32, it got converged at 44th iteration. It's almost the same as the previous case. And it's time to go with the last case of our simulation. That is an aspect ratio of 32, where we need to provide an horizontal element size as 64 millimeters. So this is an extremely distorted case where the aspect ratio is very high, that is 32 is to 1. So the width of the element is 32 times the height of this element. So here the aspect ratio is very high. This is a maximum case that we are going to try. Let's see the results. And in this extreme case, we got the solution converged in 38th iteration itself. So if you plot a graph between this aspect ratio and number of iterations, it tells us that the convergence is not purely dependent on the aspect ratio of the mesh. Or we can say the convergence is not solely dependent on the aspect ratio of the mesh. So it may be influenced by a mix of aspect ratio and skewness and some other parameters and also the solver settings. So we cannot simply say that a good aspect ratio mesh can give good convergence. So that's the conclusion from this video. Hope this video helped you. If you have any other idea or if you have any other conclusion from this video, please feel free to comment. Thank you.